right, let's look at quadratic transformations, specifically vertical translations. So our parent function is f of x equals x squared, where I have created a table and a graph to represent this parent function. Now, looking at our setup, we'll see that a vertical translation is specifically focused on D. That is whatever is being added or subtracted after the set of parentheses. Also, you'll notice that this is currently in vertex form. So in vertex form, this is our K of our vertex. Now, let's do our first transformation. I've already completed my table for my parent function. All I did is multiply the x value by itself to get the y value. Now, we're going to take this parent function and we're going to transform it by having a vertical translation of 2. So copying my x values, -2, -1, 0, 1, 2, and 3. I'm going to not only square my x value, but I'm also going to add 2 to the squared value. So -2 times -2 is +4, but +4 plus 2 is 6. -1 times -1 is +1, but +1 plus 2 is 3, and so on. I'm adding 2 to each of my y values in the previous table. Now I'm going to graph my relation. When x is -2, y is 6. When x is -1, y is 3. When x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 6. Now let's compare this graph to our parent function. You'll notice all that's happened is it moved up. Specifically, it moved up 2 units. So the parent function translated 2 units up. Let's look at another example. Once again, I've already filled out my table for my parent function, but this time we have a transformation where we're taking our parent function and we're subtracting 3. So I'm repeating my x values of -2, -1, 0, 1, 2, and 3. And this time I'm subtracting 3 from each of my y values. So now I have y values of 1, -2, -3, -2, 1, and 6. Graphing this relationship, when x is -2, y is 1. When x is -1, y is -2. When x is 0, y is -3. When x is 1, y is -2. When x is 2, y is 1. When x is 3, y is 6. Once again, we want to describe what happened to our parent function. If I were to scroll back to our original parent function, all that happened is this time it moved down 3 units. The parent function translated 2 units down. Let's look at a few predictions. Our first one says if I take the parent function and I apply the transformation f of x plus 9, I want to describe what's going to happen to it and what it would look like. My new equation would be f of x is equal to x squared plus 9. And my description is the parent function would translate 9 units up. On my next one, f of x minus 6. My new equation would be f of x is equal to x squared minus 6. And this time, the parent function would translate 6 units down. This time we're going to work backwards. Given a verbal description, we're going to write the equation form and the function. Our first one says it was vertically translated up 4 units. Well, that would be f of x is equal to x squared plus 4. In other words, that is our parent function plus 4. Our next one says it is vertically translated down 8 units. That would be f of x is equal to x squared minus 8. In other words, our parent function minus 8. And then finally, vertically translated down 1.5 units. F of x is equal to x squared minus 1.5. In other words, our parent function minus 1.5.